So hello everyone. It's really excited to be here. I said to a few people here out at the hall that this is the first meetup, live meetup that I'm presenting at in the last I think 2 years. So pretty excited to be here. Did many of them through virtual, but it's not the same. So it's really great to see you guys. Hopefully we'll hear some background noise as well. Something you don't frequently get from this virtual event. So good to see you guys. So I'm Rammy Bahalul. I'm leading NVIDIA autonomous machines business in Israel, autonomous machines and vehicles, working with many startups in Israel across many verticals on the robotics and automotive, working with universities, with corporate across the board. So many of you guys, I see some familiar faces here as well. So good to see you guys all. As Amit stated nicely in the LinkedIn, really a lot of the things that we see across robotics development, it's really how you really accelerate development. How do you robotics is one of the most complicated, I would say most of the complicated adventure of NVIDIA. NVIDIA started with many of the different businesses, but Jensen every time said, and I think it's pretty clear, AI is revolutionizing the world, but robotics is really where it comes to the edge. This is where it really gets complicated. This is where AI is really need to do multiple things, multiple tasks. Even autonomous vehicle is something that you have certain roads and you need to take certain actions. But in robotics, you have manipulation. Everything is moving around you, unlike autonomous vehicles. So it's really more complicated, much more complicated than autonomous vehicles. So I would like, in my next 20 minutes, I would try to walk you through how NVIDIA vision is how we can accelerate development of robotics. And that mainly comes through simulation. And how do we simulate the world? How do we virtualize it? So I would like to start with a clip, a very good clip that Jensen himself, with BMW board member, is really talking about how NVIDIA revolutionizing the BMW manufacturing. This is really will set the stage of what NVIDIA is doing. Because when you look at manufacturing, there are robotics in manufacturing, but how do you take and you create a digital twin in one hand? How do you really virtualize everything in the manufacturing? How do you create perception? How do you make robotics talk to other robots? How do you make human talk to robots? How you actually have everything works at the same time? This is really one of the key challenge of manufacturing. And BMW have selected NVIDIA to really create a different and a much better environment for the manufacturing line. So I would like to start with this and then we can talk.
Welcome to BMW Production, Jensen. I'm pleased to show you why BMW sets the standards for innovation and flexibility. Our collaboration with NVIDIA Omniverse and NVIDIA AI leads into a new era of digitalization of automobile production.
Fantastic to be with you, Milan. I'm excited to do this virtual factory visit with you.
We are inside the digital twin of BMW's assembly system, powered by Omniverse. For the first time, we are able to have our entire factory in simulation. Global teams can collaborate using different software packages like Revit, CATIA, or point clouds to design and plan the factory in real-time 3D. The capability to operate in a perfect simulation revolutionizes BMW's planning processes.
Are those gaskets still in the right place for you?
Yeah. BMW regularly reconfigures its factories to accommodate new vehicle launches. Here we see two planning experts located in different parts of the world, testing a new line design in Omniverse. One of them wormholes into an assembly simulation with a motion capture suit, records task movements, while the other expert adjusts the line design in real time. They work together to optimize the line as well as worker ergonomics and safety.
Can you tell how far I have to bend down there?
So we'll get you a taller one, but there's
Yeah, it's perfect.
We would like to be able to do this at scale in simulation.
That's exactly why NVIDIA has digital human for simulation. Digital humans are trained with data from real associates. You could then use digital humans in simulation to test new workflows for worker ergonomics and efficiency. Now your factories employ 57,000 people that share workspace with many robots designed to make their jobs easier. Let's talk about them.
You're right, Jensen. Robots are crucial for a modern production system. With NVIDIA Issac Robotics platform, BMW is deploying a fleet of intelligent robots for logistics to improve the material flow in our production. This agility is necessary since we produce 2.5 million vehicles per year. 99% of them are custom.
Synthetic data generation and domain randomization available in Isaac are key to bootstrapping machine learning. Isaac Sim generates millions of synthetic images and vary the environment to teach the robots. Domain randomization can generate an infinite permutation of photorealistic objects, textures, orientations, and lighting conditions. It is ideal for generating ground truth, whether for detection, segmentation, or depth perception. Let me show you an example of how we can combine it all to operate your factory. With NVIDIA's Fleet Command, your associates can securely orchestrate robots and other devices in the factory from mission control. They can monitor in real time complex manufacturing cells, update software over the air, launch robot missions, and teleoperate. When a robot needs a helping hand, an alert can be sent to mission control, and one of your associates can take control to help the robot. We're in the digital twin of one of your factories, but you have 30 others spread across 15 countries. The scale of BMW production is impressive, Milan.
Indeed, Jensen, the scale and complexity of our production network requires BMW to constantly innovate. I am happy about the tight collaboration between our two companies. NVIDIA Omniverse and NVIDIA AI give us the chance to simulate all 31 factories in our production network. These new innovations will reduce the planning times, improve flexibility and precision, and at the end, produce 30% more efficient planning processes.
Milan, I could not be more proud of the innovations that our collaboration is bringing to the factories of the future. I appreciate you hosting me for a virtual visit of the digital twin of your BMW production. It is a work of art.
Okay. So, what I like about this video clip is that it's really walk you through. If you really manage to catch all the details that Jensen mentioned, we'll talk about each of them separately later on. So if we start from ground zero, NVIDIA believes that everything that moves will become autonomous, and I think this is the reason that all you guys are here. Doesn't matter if it's one wheel, two wheels, four wheels, a boat, delivery robots, and you see that this span across different verticals. And NVIDIA is working with all the different verticals. We in Israel, only in Israel, we have basically autonomous machines / robotic startups almost across all the different verticals that you can imagine. If it's smart city, industrial automation, automotive, so on and so forth. So it's really broken down. Now, when you look at the at robotics and Isaac, by the way, just to set the stage, Omniverse is a new tool that NVIDIA have come up with in the last 6 to 9 months. And Omniverse is basically the way to virtualize the world, okay? Just some people ask me what's the difference between Omniverse and Isaac. So it's really a way to virtualize, to create digital twin. It really go across different verticals, not just robotics. So Omniverse is really a top strategy for NVIDIA to create virtual world. Isaac, on the other hand, is NVIDIA SDK and NVIDIA tool to create robotics. So it's obviously used a lot of the features and enhancement of the Omniverse to create virtual world, but Issac, as you'll see, have many more tools and SDKs that allows you to build robots from A to Z. So when we look at this, we actually see a supercomputer on one hand, and we see a Jetson or embedded on the other hand. So really, to build robotics, you need these two different entities. One is really to write the AI, to train the AI, to train all the perception algorithms, segmentation, and so on. This usually run on a supercomputer, either in the cloud or on-prem. But after you develop your software, and this is where Issac tools run. But when you develop your software, then you go and run it or deploy it, the way you like to say it, on the edge product in your robot. So this is the way it works from training all the way to inferencing. Now, when you look at the Issac robotic platform, it really spans from different modules. It goes first. You need to do data collection. Then you need to train, develop, simulate, and then deploy. So it goes really back to the previous slide, but here we really broke it down to many different functions. And when you really develop a robot, you really cannot skip any of these portions. You really need to go and collect data, either collect data or create synthetic data from Issac. Then you need to train, again, either train through a real data or synthetic. Then go and develop all your AI. And by the way, there is some loops going on here that are not really shown on the graphic, that really goes all the way from each one of this. You'll go back and collect more data and simulate it. And then at the end, you deploy and manage. And when you look at the platform, you go from DGX to EGX to the AGX. AGX is the Jetson platform that deployed in the robot. So Issac SDK is really a way for us to be able to help you to create all these different elements, from developing the algorithm all the way to simulation. Now, I think this is really the most important slide to comprehend when you look at robotics and NVIDIA. When you actually look at developing robotics, you have to have a complete software stack. That at the bottom, at the core of it, the platform, the hardware platform. On top of the hardware platform, you usually have the different hardware accelerators that are being used. And then as you go up the stack, you have sensor models that are being either developed or being used by different startups. Depends what sensor you are using for the robots. Then it goes to the GEMs, which are the algorithm that NVIDIA developed for the robotic ecosystem, for the robotics startups, that you can actually, when you start developing, you can use those GEMs out of the box. Those GEMs are NVIDIA designed, NVIDIA trained, but obviously some of them are working with many partners like yourself. Some of them are available online, but these are things that are coming with the Issac kit. Those are the Issac GEM, and we'll talk about this in a second. And on top of it, you have what we call the reference design. If it's a JetBot or a Kaya or a Carter, those platforms are NVIDIA platforms. We really develop a complete robot with the Jetson in, with this complete software stack that we sell, that startup companies can buy or a corporate can buy and start testing the robot in different environments. So you can see that it's not only the hardware when you come to develop a robot, it's the complete software stack, and on top of it is obviously the Issac Sim, creating the simulation. We'll talk about this.
Carter, look.
So this guy, don't be surprised, this is the guy that is really talking here in the background. He's training the ASR. So ASR
Oh no, Carter, bring me a sandwich.
is one of the gems that are provided, because when you actually have a robot, you need to be able to talk to the robot and to communicate, to converse. But outside of this ASR, you have many different jams spanning all the way from localization, path planner, depth estimation, object detection, and so on. So when you really get yourself to develop a robot, you have your secret sauce as a startup or as a company, but you really don't need to develop everything. You can really get all of this that are really trained to 90%. You can take them and transfer learning. What we have a transfer learning toolkit that you can take any of this network that we train and you can transfer them to your environment. So if you need object detection of different objects than we train, you basically use transfer learning. So those jams are ready for everyone to use. Now, next is all the simulation. It's really the navigation, manipulation, perception. If you look here carefully, you'll see how a developer is really developing using Issac. You're basically able to go and really manipulate the path planning of your robot. So this is your robot, and you really want the robot to come and go from point A to point B, and you are able to play with this. You're able to graphically move your robot from different point and put obstacle and see how you can train it. So when you look at the Issac and you're breaking down to different functions that we have brought this year, you basically can see that we have Visual Slam that is really able to develop and to show you localization. We have a function called Issac RC remote control that with very low latency, you're able to use the cameras and be able to remote control your robot. Those are all built-in functions that come with Issac, and this is the new Carter that have been developed with the BMW. Navigation scheme, those are a function of Issac. You can actually do a 2D LiDAR slam. You can be able to do a path planner and trajectory validation. So those functions that you typically will go and develop yourself are built into the tool. And one of the things that is really important when you go to manufacturing is 3D pose estimation. So being able to not just do the 2D, but being able to do the 3D. This is now coming as part of the jams, and the part of the Issac Sim integration are the functions you've seen in the beginning in the clip of the BMW. You've seen different detection, segmentation, and also reinforcement learning that are being used by the new SDK. Those are additional features. So I'll just jump to straight to the end. So whenever, if any of you guys is developing robotics, interested to learn more of Issac, those are the two links of Issac SDK and Issac Sim. Welcome to join. Welcome to obviously contact me directly if you have any specific question. How do I get Issac? How do I start learning? How do I get early access? And I'll be more than happy to help you guys. This is my contact info here, and it was great talking to you guys. If you have any questions, I see that you're running late, but you can catch me in the break anytime and have any questions. Start with any question. Thank you very much, guys.